Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the valley curves. The valley curves are formed in any one of the cases illustrated in this figure. In all these cases, the maximum possible deviation angle is obtained when the descending gradient meets with an ascending gradient. There is no problem of restriction to the sight distance in the valley curves during the daylight. However, during the night driving under the headlight of the vehicles, the sight distance available at the valley curve is decreased. As we can see from the figure A, the decreasing gradient meets the decreasing gradient. In this case B, the decreasing gradient meets the flat road. Figure C, the decreasing gradient meets the rising gradient, and figure D, the rising gradient meets the rising gradient. So in all these cases, when the descending gradient meets an ascending gradient, there is no problem of the restriction of the sight distance in the valley curves. The important factors to be considered in the valley design are that the impact-free movement of the vehicles at the design speed or comfort to the passenger. That means no any sort of a discomfort or an impact has to be experienced by the passenger, and to provide adequate sight distance under the headlight of the vehicles during the night driving. And third is locating the lowest point of the valley curve for providing suitable cross drainage facilities. The valley curve and its length are designed as a transition curve to fulfill the two criteria. First is the allowable rate of change of the centrifugal acceleration of comfort conditions, and second, required headlight sight distance for the night driving. So in the first case, the length of the transition curve LS for the comfort condition is given as LS equals to V cube upon CR, where the value of R at the length L S equals to LS upon N, which is equals to LS equals to V3 upon C into LS upon N. That equals to V cube into N divided by C into the length LS. So LS square will be equals to V cube into N upon C. So LS will be equals to, in the bracket, N into V cube upon C raised to 1/2. And L equals to 2 LS, that equals to 2 into NV cube upon C bracket raised to 1/2 or 0.5. If V is in kilometers per hour, then L equals to 0.38 in the bracket NV cube. Here it should be noted that it is not V3, it is V cube raised to the bracket 1/2, where the L is the total length in meters of the valley curve, which will be equals to 2 LS. V or capital V is the design speed in meters per second or kilometers per hour. C is the allowable rate of change of the centrifugal acceleration, 0.6 meters per second cube, and N is the deviation angle, that is algebraic difference between the two grades. P, when the length of the curve for the headlight sight distance. The length of the curve for a headlight sight distance may be determined again by the two conditions. First, when L is greater than the stopping sight distance and when L is less than the stopping sight distance. So the first case, when L is greater than the stopping sight distance, The length of the valley curve L is assumed to be greater than the headlight sight distance, which should be at least equal to the stopping sight distance. So let, in this case, h1 be equals to the height of the headlight and alpha be the angle of the beam of light. Since the sight distance will be minimum when the vehicle is at the lowest point on the sag curve, if the valley is assumed to be of a parabolic shape, and if the average height of the headlight is taken as h1 equals to 0.75 meter and the beam angle alpha equals to 1 degrees, then L equals to ns square. Here s2 should be read as s square upon 1.5 plus 0.035 into s, where L equals to the total length of the value curve in meters, where L is greater than S, and S equals to the stopping sight distance in meters. N is the deviation angle, which is equals to N1 plus N2, and with the slopes minus N1 plus N2. In the second case, when L is less than the stopping sight distance, the general equation of the length of the valley curve is given by L equals to 2s minus in the bracket 1.5 plus 0.035 s upon n, where n is the deviation angle, that is the algebraic difference between the two grades, and L equals to the total length of the valley curve in meters, where S equals to the stopping sight distance in meters. With this we shall stop. Thank you.